Welcome back to the shop and to the channel. We are back to work on making some new parts for the K&T Universal Milling Head. You might recall from that previous video that I did a test piece in delrin of the spline shaft. I wanted to make sure I had all my calculations correct. The finished piece in delrin came out just perfect. I couldn't be happier with it. Although I did make some adjustments to my drawing while I was cutting this. And I've since redone that drawing and I'm ready now to make this out of steel. I am going to be making this next part out of steel, but it will be another test piece. I only have so much of this material and I don't want to waste it if I screw up again with my measurements. Even though the delrin piece came out fine, I just don't want to risk it here. So I'm only going to make a shaft that's about 6 inches long. But before we do, I'm going to go ahead and swap out this 3-jaw chuck to the 4-jaw. I don't really trust the concentricity of the 3-jaw, and since this material, this 1045 that I'm using, is turn polished and ground, I'm going to take advantage of that and dial it in with 4-jaw. The piece of material I have is 1.5 inches in diameter, and the majority of the shaft will be turned down to 1.25 inches, but there'll be one small piece that will need to be about 1 inch and 470 thousandths. So I have about 30 thousandths play to deal with, but rather than mess with the 3-jaw, which is not going to be 30 thousandths out, but I figure the 4-jaw, putting it on here really isn't that hard, and it's always good practice to dial something in, so why not just put the 4-jaw in and have a little fun dialing something in. I've cut off a section of the stock that will leave me plenty for the real piece, and this will also give me some idea if I've made it long enough for what I want. So once I get the other jaws swapped around, we can chuck it up and start dialing it in. I'm making a Sharpie mark here at around 4 inches from one end. I figure that's about what I'm going to need on the dividing head side of the work holding when I get this into the horizontal mill, because I'm going to need to leave some space for the cutter so the cutter doesn't end up running into the dividing head, which from what I understand it would be bad. I have a Brown and Sharp indicator here. It's a thousandths indicator in this articulating arm that I'm going to use to dial this in. Right now I'm going to set it so it's actually floating above this piece, because this is fairly off from center, and I'm just going to push these jaws around until I get this a little closer to centered before I really start to dial it in. Well, unfortunately, the jaws on this 4-jaw are so bell-mouthed that I'm not getting a good grip on this piece to begin with. So I have some aluminum inserts that I made a while ago that I'm going to slip over the jaws here, and at least with them being softer, I should get a better purchase on this piece of round bar. One of these days, if I ever find a suitable tool post grinder, will turn grinding these jaws into a project. Well, that feels a bit more grippy in the jaw, so we'll get the test indicator back into position and start dialing this thing in again. Well, that's within thousandths of an inch, and I'm pretty happy with that. So I'm going to move this down to the end. I'm sure this will have quite a bit of run out, and we'll use a hammer here to kind of knock it into submission, or rather into concentricity with the other end. Well, I think that's pretty good. That's within a thousandth of an inch. So I'm going to move this back down to the end closest to the chuck, and we'll check that, and we'll make any adjustments I might need to make here, and then we'll check the far end again too. Well, I like it. I think we're going to call that good. Well, with the lathe turning now, you can see that's running pretty true. I'm pretty happy I spent the time I needed to in order to get that dialed in good. So we'll bring in the drill chuck here with a center in it, and we'll drill it for a live center. Now I need to turn down this first section of the shaft up to the tick mark there I made with the Sharpie to about 1 inch and 250 thousandths. I can be a little bit under that by maybe a thousandths or two, but I don't want to be over that because I think that could cause some binding issue in the mating part that has to go over the shaft. Well, because this is a 1045 alloy, I fully expect that this is going to be a little bit of a challenge to turn. This little lathe just doesn't have the horsepower to take the deep cuts that carbide really wants on this hard of a material. And as I suspected, I'm getting some really stringy chips here, so I might need to reevaluate if I'm going to use this insert or try a different one. I'll use a little bit of oil here and then dial in a much heavier cut and see if I get a little better chip control. Well, that's certainly not a stringy chip. It's a little better chip, but yeah, I really don't think this little lathe just has the guts to do it. So I'll back off here and continue down here with this lighter cut, and of course that makes the chips really stringy. So I think after this pass I might switch out to a different insert. I'm going to turn off this little step that I created in the last pass before I switch out inserts and take a measurement just to see how much more I need to take off. Well, I still have about 188 thousandths to come off the diameter. So I think I will go ahead and take out this tool holder and put in one with a CCMT insert in it and see if that does a little bit better. The insert that's in here right now has a really sharp nose radius, and it is also ground, so it's much sharper, and it's designed for softer materials like brass and aluminum. So I'm going to put this other one in here, which is designed for, alloyed steel. It's a sintered insert, which means it's formed only under pressure and it's not sharpened or anything. So we'll see how this one does. Maybe it'll act as a good roughing insert and get me closer to my final diameter. Well, these chips are still stringy, but at least they are a little curly. So I think if I go a little deeper in my depth of cut, I might get this thing to break a chip. Maybe not ideally, but I think it's certainly better than having a bunch of angel hair pasta in my chip tray. So I'll take this over the previous stuff any day. I have about 170 thousandths yet to come off of the diameter, so I'll zero out the dial on the cross slide so I keep track of that, and then I think I'll dial in 30 or 40 thousandths to come off the diameter, so that's 15 to 20 thousandths depth of cut. Well, it's still not an ideal chip, but it's one I can live with. It's breaking off about every inch, inch and a half, which again is way better than the stringy chip I was getting at the beginning. So maybe I can try a little deeper cut on the next pass, but if I can consistently get this through this process of roughing it, I'll be happy. Well, I made this little chip shield a little while ago, and this is actually my first time using it. All it is a cheap import articulated arm DTI holder that I bought from AliExpress for maybe like $12 or $13, I think. And then a piece of acrylic that I picked up from Menards and cut down to size. I mounted it on here and use a little mag base, which is probably a weakest mag base I think I've ever used, but it works for this. I would never use it for a dial indicator because I think it would just fall over. Well, I'm going to let this cool off a little bit and then come back and take a measurement and see where we are. Well, I let this cool down for about an hour and a half or so, and it looks like I have about 7.5 thousandths to come off the diameter to hit 1 inch 250. Well, the surface finish on that last cut was terrible. I only went a little ways in before I stopped and decided to change back to that ground insert. I'm hoping that I will get a better surface finish. I've got a good surface finish on it now, and I really don't want to lose that. Well, unfortunately, I did lose that nice shiny surface finish, so I think once I get this to size, I'll use a little emery paper and maybe some Scotch-Brite to see if I can't polish this up. Does it matter in the long run? No, definitely, but we all like to have a nice shiny surface finish when we're done milling, and I'm no different. I do want to clean up this face where the live center is, and I don't want to take the live center out. So I think I'm just going to stick this DCMT insert back in and get as close to it as I can. I'll clean up the rest of it later, but I want to get at least the majority of this end faced off and clean. Well, and of course we have to chamfer the end, right? Otherwise we'd just be animals. Well, I have a parting tool in the lathe right now. What I'm going to do is cut a notch in it. I'm not going to part this all the way off, but what I'm leaving is a section that's identified on the drawing that's on the original piece. And I'm only doing this as a visual indicator to me when I get it over onto the K&T as to how far I'm going to need to cut through. Because I do plan on finishing this other end, again, just as a trial run. So I want to get the features as close as they would be, minus the length, in the final product. With what I believe is all of the turning operations complete, I'm going to spend a little bit of time and at least try to get this surface finish a little nicer. I don't like this dull finish. Again, does it really matter? No. Is anybody going to see this piece? Well, this one right here might actually sit on my shelf, but the final product is going to be buried inside of the Universal Head, so no one's going to see it most of the time. But I guess like any other hobby machinist, it's a matter of maybe a little bit of pride and I guess practice in making parts that you wouldn't mind presenting to somebody else. Well, that surface finish is a little bit nicer now after a little bit of polishing, so we can take this out of the lathe and over to the K&T. I will go ahead and get this all set up off camera, and once I get the cutter aligned to the zeros, I'll bring you back. Well, I got this all lined up underneath the cutter, setting what I'm calling my zero, so now I need to go ahead and move the saddle and the knee in order to make the first cut. I'm not going to go into any detail on how I'm making these cuts and how far I'm moving things. If you want to learn a little bit more about that, I've got a link to the video I made for the test piece made out of delrin, and that goes into a little more explanation. The primary reason why I am running this test again, but in steel, really is to experiment a little bit with feeds and speeds. You know, what would be the proper RPM here, and what kind of a feed rate should I be using in order to minimize any kind of chatter or bad finishes. I want to get a good finish on this part. For this first pass, I'm running 60 RPM and 1 3/4 inches per minute on the feed rate, and I'm going to start ramping this thing up faster as I make passes for each of these splines. that's the last pass to form all of the splines. But before I take this thing out of the dividing head, I want to move the footstock out of the way and slide the gear over it just to see if everything fits right, or if I need to adjust my measurements and maybe go a little bit deeper. I won't have to try to set this thing up again. Well, here it goes, the moment of truth. Well, and I gotta say, wow, that just feels so good. It fits on there really nice. I don't have to cut anything any deeper. As a matter of fact, I could probably shallow these up just a little bit, but I'm not going to. There's a little bit of backlash in those splines, but I think this is the fit that I want for this. I don't think I want it any tighter. I definitely don't want it any looser. Now I feel more than comfortable of taking this piece out of the dividing head. It's going to need some deburring. We'll take it over to the bench and get a closer look. I'll get a little closer look here. I still have to deburr this, but I think it's good as it is. The gear fits on here really nicely. I'm really pleased with how well it came out. There's a little bit of chatter marks in here where I forgot to tighten the footstock, but we'll try not to make that mistake on the real piece. I am going to finish this test piece, even though it's going to be short, and by finishing it, I mean I need to cut it off and machine this protrusion on the end of it that fits a bearing. And in order to do that, I'm going to need to chuck it up on the lathe that has the larger spindle through bore. My 1942 South Bend lathe has a 1-inch through bore, and being that this is 1 1/4 inch, it won't fit in there, so I need to use the 1960 South Bend lathe. Well, it's my intention to use this 10-inch 4-jaw chuck on that 1960 lathe in order to dial in concentricity so I can machine that protrusion for the bearing. But I don't have a backing plate for it. Luckily, I have this partially machined backing plate, so I've got a little side project coming up before I can continue with this project. But that's going to have to wait for another video. Well, if you like the video, please give it a thumbs up. Your comments are always welcome and appreciated. Subscribe if you're not a subscriber. Thanks for watching, and we'll see you on the next one.